I'm Brian Christner, and this is The Byte, a bite-sized podcast about containers, cloud, and tech. Welcome back to The Byte, episode number 56. Joining me today is Gianlucca Abrezzano. Hi, Gianlucca. How are you doing?
Hey, I'm good, thank you. As we say, it's spring outside, so you will hear birds making their sounds. And yeah, everything is good. I'm very happy to be here. Thank you for having me.
Great. So just a bit of background about Gianlucca. He's a Docker captain from the original batch, so the OG Docker. So when was that? 2013 or so, I believe?
Yeah, I was in Dublin where it happened, so it was at least three, four. Yeah, a lot of time, a lot of years ago.
And currently, Gianlucca works as a site reliability engineer. He's member of the Kubernetes SIG Release team. And as you can hear in his beautiful accent, he lives in Turin, Italy, and he likes hiking and skiing in the Alps. And
That's it.
as you hear in the background, you hear the beautiful birds singing and everything, so it's just great. You can find Gianlucca online at Twitter, Jean Arab, and Twitch, John Arab. So before I get going, I want to know about your Twitch channel because I was checking it out and it seems pretty cool. You're doing like live coding, you're reviewing different things.
Yeah, I mean, it's a new experience that I started during, the lockdown. So I'm kind of looking for new way to share what I do, and in some way, Twitch, I you know it's weird because I don't know why somebody should check me coding or why I should check somebody else coding, or at least that was at the beginning. But I mean, it's cool. When I do open source, I try to switch it on and see if somebody show up to say hello. So if you are listening and you like Twitch, just see you there. I don't have a schedule yet, or I don't do anything too seriously there. It's just sharing a couple of hours with you, and yeah, let's see if it works. Yesterday I also try to have a little bit a bit of more like structured content where I share a chat with somebody from the community. Yesterday I I had a chat with Carlos, that is one of the maintainer for Go Releaser. Like, it's the maintainer for Go Releaser, that it's a very popular tool in Go to manage release lifecycle for application, and with Tibor from Docker, that is currently working on BuildKit. And
Yep.
yeah, I mean, there is a common a few of common concepts in those tools, and I saw the opportunity to have a good chat about multi-architecture for Docker images, and we had a chat. It got streamed on Twitch. A bunch of people show
Nice.
up, so it was cool.
Really? How is the attendance?
Well, I mean, silent, but I saw that they was there. So in some way, I would like to see more interaction, but it's also hard because I don't really have a good connection here. And for streaming, you have to have a good one. So I presume there is a little bit of latency and friction on the technological situation. But yeah, it's cool. It's not too hard when you figure out all the setup you have to do. So it's good. I think I will keep doing it for a while and see how it goes.
Nice. Okay. And so currently you work as a site reliability engineer. So what does that mean for you day to day? I mean, what's your tasks? Walk us through a typical day, I guess.
Yeah, I mean, I started as a SRE because I have a developer background, so I started doing development in PHP. I moved to Java, Go. I made a bunch of Node.js and JavaScript stuff. So I'm solid on development, but I also discovered really quickly the powerful of cloud computing, because
Yeah.
I started coding and AWS was already there, so I didn't have the opportunity to hook cable together or enjoy that part of development. But I quickly learned that AWS API are powerful, and as a developer I can do a lot in the automation phase. So I quickly moved to DevOps, and I try to write code for the infrastructure. And in
Okay.
some way, I end up in that particular area. And the evolution for me was to find a company that was willing to build like a SaaS offer. And when you build a SaaS, you have to keep in mind like what reliability is. Maybe you have DevOps that are doing the operational side, but also the developers have to be on board on the fact that their code will end up in production, and they have to figure out what's going on, and they have to understand how to write code that is understandable and debuggable. So I think my role as a SRE, or the way I see the SRE right now, is a developer that has the mindset and the skills to look at the code and say, oh, this is how you should instrument it, or this is tips that, or a log line that you should have, because I know that like operationally it makes a lot of sense.
Clear. And I mean, that kind of leads me into my next question is like, what's your interpretation of SRE? Because we hear this term used quite often. And for those that don't know, it says site reliability engineer. It's like developed by Google, but you know, we have DevOps, we have SRE, and what's your interpretation of the two? Do you see commonality between them, or?
Yeah, I see they are kind of, let's say a consequence of each other in some way, because definitely Google like built the terms, but there are a very few Google-like company in the world. So
Exactly.
everyone kind of took something out from the SRE, like Bibles that they are writing with O'Reilly. That, by the way, are all in my bookstore. So
Same here.
bookshelf.
And the new version, it's on my to-do list.
That's it. Yeah, I have it in my wish list of AWS on Amazon, so it will come at some point, I'm sure. So the way I see the evolution is like, we like back in the day we had those two silos that was developer and operations, and in some way we kind of tried to match to put them like more close to each other, and we started to ask like ops to write code, to do infrastructure as a code. So I think DevOps in some way required a lot of like learning from the operational side, but the developers didn't really like get much. We as I did, like probably some developers shift closer to operation because there is some code to do and some practice are now common. We have more practice in common, but developers didn't really had to do much other than like suffer or live closer to closer to operations. And I think SRE are probably the other side of the spectrum of what DevOps is. So are developers that knows and take care about like how code runs in production, if it is like efficient enough, or if it is like, as I said, easy to understand from the outside. I think that's crucial for how operations and systems are built today. Like we have on-call shift from people from different teams because everyone develops its own services. So in some way, at some point, you will end up like looking at somebody else's code, somebody else's services during an outage, and in some way you have to develop and you have to have in practice like a common language that you can rely on, at least to scratch the surface and see how it performs. So I think that's the way I see the role of SRE at normal scale, let's say. So definitely SRE are not the person that manage Kubernetes or that knows how to deploy Kubernetes. That's a good skill, but it doesn't need to have a title by itself.
Sure. So I mean, some of the more important things is like I think you mentioned is for multiple teams to be able to assist, you have to have some sort of standardizations so one team can jump right in and start helping. Do you see it that way, or how do you see multiple teams working on the project together?
Yeah, I mean, definitely. At the end of the story, we are here and we work to, match some business goal. And the business goal is is driven by the company itself. So everybody has the same business goal, or it should have the same business goal. So even if we write two different pieces of code and then it goes to the same, like the target is the same. So I'm sure that at some point you will have, or I had to look at your code and you are mine, and because I can be awake like 24 hours a day for 7 days a week. So at some point
I hope not.
Yeah, at some point we all have to go out and enjoy like our life outside. Not now. Now we are all home, but at some point
Sure.
you will have to do it.
It's coming. It's coming.
It's coming. Yeah, the day is close. So, or at least I hope. And so yeah, we definitely have to develop some common like practice that will help everybody to be on the same page. And there are some like techniques that we can use. So and some of them comes from Google and from the SRE book. So you have to read them and to take what you need as a company or what you think is useful. So Google has a concept of a page that is called Z index, and it's a page that every application expose in the Google side, and they use that to figure out like it's made in the same flavor across all the services, and it's used to measure like some very common like measurements like the latency or the CPU usage or things like that. And it means that everybody can just open that page that runs the same port on the same path for every binaries, and you just look at it and see what's going on. So this is like a very small example, but it can be the same like the same fields in the log or stuff like that you can kind of leverage. So there is definitely something in that space that has to be done, and this is why I think that developer has to develop. Yeah, that's the the habit to do that, because it's their responsibility, because they touch the code and they are there.
Now, the next question is more going to throw myself under the bus, because it's something along the lines of SRE generally. So do you find the SRE term is overused? And this is something, our company 56k.cloud, we consider ourselves all SRE engineers. We are doing the work, but we also hear a lot of companies and business units throwing SRE around, and they're not even implementing it. They're just calling themselves the new SRE. Do you find that as well, that the term is being overused?
Yeah, for sure. I mean, as I said, like a few minutes ago, SRE are not the DevOps that knows about Kubernetes, Istio, or the cloud native stuff. So if you, you can call them in that way, but there are probably better terms to say that. So there is definitely, Google is doing a lot, is investing probably a lot of money on the terms itself. So there is definitely companies that are, using the terms to look cooler, and it means like both sides. Like there are companies that maybe are consultants and they try to sell themselves better as SRE because it sells better at this point.
Yes.
Or there are companies that use SRE in the job title, even if you won't end up like doing whatever it. And also like the fact
Excel sheets.
Yeah, that's it. Yeah, so there is a little bit of like unicorny like flavor on the terms for sure. But it's also driven by the fact that as we started, like the terms itself isn't really developed or strict. Like if I look at the software engineer title, I know more or less what I'm gonna do, even if I coolest company using the latest like version of every like language that they use, or I can end up in the oldest like environment ever. But I still have, even in that term, there is a big spectrum of possibilities.
Absolutely.
And the terms is like how many years old? I don't even know. So I wasn't there when the terms got.
We're just inheriting it all.
Yeah. In this case, it's even worse because like the terms is like maybe 3 years old for the public like landscape, and there is also a lot going on in the landscape of development in this side, like Kubernetes containers and GitOps, all this kind of stuff. Distributed tracing, they just got all the public like along those years. So there is definitely a lot, and I understand why it's happening. I don't think it's bad. It just require like if you know that you can it makes everything. You just have to do to make the right questions when you approach the term or the company or whoever you have in front of you.
Okay. You mentioned traceability, and this kind of brings up another topic is since SRE is really metric driven and relying a lot on information that you're gathering from your applications, how do you see, or what are the benefits of observability and telemetry in applications?
Yeah, I mean the one of the main issue or one of the main point is that it really depends like languages by languages. So every language is different. There are languages like Python and Node.js where you can almost trace or instrument your application from the outside, inspecting like every point of the application. Java is the same. You can use the JVM and kind of figure out and trace or monitor every bit of your application from the outside, and that's a very good benefit when you do my work, because it means that you don't have to ask developers to do whatever they're supposed to, because you can do it by yourself. There are other languages that, or you can do it when the application is running. It's even better. For other languages like Go, it's harder because you have to instrument the application in the inside, and this is usually a problem, or it creates some friction because developers want to have abstraction of abstraction, and there is never enough layer of abstraction on it. So it's more complicated, and I mean I understand why it's needed, so to avoid vendor lock-in or things like that, but it's more work that has to be done. So definitely depends on your language, but the ability to understand the state of the application from the outside is critical. And in this environment where we have like pods or VMs or EC2 that comes very quickly, it's very hard to figure out or troubleshoot something live. In some way, you also you always have to get a picture from the application, like a snapshot, and look at it later. And this is important when the outage is happening, but also when you figure out that you had an outage like yesterday, and maybe it recovered itself because we have all the resiliency in place. I mean, we made a lot of work on Kubernetes or EC2 or cloud providers. So we have we need to have some more resiliency in our hands. Otherwise, all this like work is a waste of time. So if you develop like containers, if you use Kubernetes, if you are on cloud, you definitely have some resiliency in your like budget that you use. So by consequence, it means that if you have an outage, it shouldn't like wake you up or become a disaster, a universal disaster, like every time. It should be able to recover itself, but it doesn't mean that you don't need to troubleshoot what's going on, because it can repeat or it can become worse. So this feeling of this needs to troubleshoot something that happens like way back in the days or in the hours will may be new for a lot of like people, because we end up like we are very good at being proactive, because all the tools and all the operational experience we had were driven by like the ops side of the world. So the ops side see cables, they see CPU spikes, so they are very, very like proactive. Like something is happening, I'm gonna fix it, and if I can fix it by myself, I will call a developer. But this is not how it works anymore. There is an outage, the system recovers, so no operation involved, and the problem is fixed. when you wake up. But you still had the problem. You had the problem. Some customers didn't, get
you still need to
the
investigate.
response.
Yeah.
Yeah. So how do you do that? And the idea is that you take the snapshot of your application for later.
Well, actually, this is it's actually a funny time because this is the perfect COVID podcast because Gianluca has the nice birds in the background. I have somebody mowing the grass outside my window. So this is brilliant. Anyway, you said it'd be good if you can do a snapshot of the application. And this actually leads us to one of your projects that you're working on, correct? This is Kube Profefe. Did I say it right?
Yeah, is Kube Profefe? Yeah, because it's like the project itself is called Profefe. But I think this discussion, like taking the snapshots of the application, is it's very abstract. But what does it mean in practice? As I said, it really depends on the language. But when I think about snapshot, I think at least about 2 points. One is the trace. So when you build a trace from your system, you end up having a graph of the request with a lot of details, and more you instrument and better you instrument, more details you have that you can look at. And that distributed tracing can be one of the way to take a snapshot. Another one is the profiling. So every application, every runtime has a way to get profiles. And what I mean with profiles are the tar or the blob that contains like information about the runtime of your binary or the process itself. So you usually split by functions. So you have all the functions and you have the hierarchy of them, and you have the latency, how much the process spent in that particular function. And with the JVM, you can take the profile from the JVM. PHP has its own way. Go has its own one, and I develop in Go a lot. So Profefe is like a registry when you can store all your profiles. So in Go, you can instrument your application to get profiles by itself, or you can expose a HTTP endpoint, and you can ping that endpoint. The endpoint will give you a tar that you can store in some place. And Profefe does that. Profefe helps you to do that continuously, because as I said, like it used to be common to have this workflow. Like you get a call from somebody and says, okay, your application is like looking weird in production, so take a profile and look at it, and that's it. Problem solved. You look at it, you see that what it says, and you fix the problem in the best case scenario. But now nobody calls you, because the system usually recovers by itself, because maybe you are very close to go out of memory, but Kubernetes has the right limit, so it kills your application restarts. You have other replicas of them, and you got really close to learning something from your application, because out of memory is always a chance to learn something new, but you waste it because nobody asked you to get the profile.
Exactly, and it's constantly Kubernetes is recovering it in the background, and you never really see it, or no one ever reports it, because Kubernetes is kind of recovering the error for you.
Yeah. When somebody reports that, it's worse than ever.
Yeah, it's way worse.
Before. So there is always a situation where somebody will gonna call you and say, oh, we have a problem, like we can't recover, or it recovers too slowly, so something is going on. But usually is the level to get there is way far away than what it used to be. Because we have a resiliency budget, and that in some way helps us, but also requires developers to be more aware of that. And one of the way to solve that issue is to do continuously profile your application. So you don't know when the application will require a profile, but you know that at some point you will want it. So the solution is to set up a pipeline that every once in a while ping all your application, takes all the profile, push them in a repository that you can use later. And this is this is what Profefe does. And I worked in the in a bit of code that's called Kube Profefe, where Kube stands for Kubernetes. So I built a bridge between Profefe and Kubernetes. So it works. It's well integrated with the flavor of Kubernetes, at least for what I can tell. So you annotate your pods with particular annotations, and there is a process, a cron job that goes over all the pods, looks at the one that have the right annotation, gets the profiles, and push the profile into Profefe. By consequence, Profefe exposes an API that you can use to retrieve those information, or that you can, and it stores them in a different location. Like in our case, we store them on S3, Amazon
Nice.
S3.
So then you can compare profiles over time, and between version upgrades, etc. So that'd be extremely helpful. Yep.
Yeah, that's the idea. And like the project is very like in the early days, but it's working. Like we use it in production, and we are happy with that. There is definitely a lot more that we can do. For example, we tried to when the profile goes to S3, we can use AWS Lambda to parse and read programmatically the profile, and we can translate it to like metrics that we can push in like InfluxDB or in a time series database. And as soon as we have the profiles well translated and pushed in InfluxDB, we can do queries and we can do analysis on it. So because they like if you set up like a continuous integration pipeline, you get a lot of information that you don't use until you need them. So the idea is that you can also automatically analyze them and trying to figure out if there are trends that predicts future degradation or change of performance.
So I mean, you can do a lot of automation to these profiles just by putting it into an Amazon bucket. You can already, like you said, you can have a Lambda function kickoff and like clean up the data, put in time series, and then you can, when you wake up in the morning, it's already there for you, right?
Yeah, that's it. Yeah, and like one of the reason about why I got in love with Profefe, I decided to take it over and use it in my company, other than building my own solution, is because the work around the API was already done, and the code is good, so there is a good abstraction for the storage, and the boring part is always to figure out the right API. When you have the right API, you are super powerful in your workflow. So Kube Profefe, other than exposing the collection mechanism, also expose a kubectl plugin that you can use. So you install the plugin and you can do kubectl Profefe capture the name of the pod, and it gives you the profile in your local laptop that you can use. Or you can do kubectl Profefe get profiles, and it gives you the profiles that it has in the registry. So nice. You can really create a workflow that doesn't go too far from what your developer are using. In our case, we spent like a year trying to move everybody to Kubernetes. So we waste a lot of money, a lot of time, or we invested a lot of money, a lot of time on that. And why you have to learn about a new tools? Just embed it in your workflow, because that's why we invest so much time.
It increases adoption if people are familiar with the workflow already. So yeah, it's a smart move.
Yeah, that's what we did, and it has room for improvement because everything has room for improvement, but it works.
And just to discuss some of your other projects you're working on, Open Telemetry, you're also a contributor to that. So that kind of plays into the observability part of this. What's your role in that project?
Yeah, I mean, I'm not a contributor in terms of code. I just think that distributed tracing is a topic that we all need to know and to use, but the ecosystem around tracing is like very hard and very like not well designed yet. And this is because as I said, like to have a good trace that goes across processes, it will may go across languages, it will may go across different like transport layer, TCP, UDP, HTTP, a queue. So how do you build an ecosystem that makes everybody to agree across languages? It's impossible across a JavaScript framework. So like, how can you do that in a language, across languages? So it's a very hard like problem, but as soon as you start to do tracing, you get a lot out of it. So I think, and that's the reason about why I'm involved like in being the first one trying all of them, being the first one writing or speaking about those, because even if we didn't figure it out, and maybe we will never figure it out, because vendors are playing their role, like open source project has their own marketing department nowadays.
Yes.
So it's definitely hard, and there is a lot of like friction or collaboration, friction in collaboration. So, but yeah, I like the topic. Open telemetry Open telemetry is the great example of this friction. Like we had open tracing a few years ago that went out, and it's an open source like standard to do, or attempt standard to do distributed tracing. So it's a way that you can use to describe a trace across languages, across like everything. At some point, Google started to release like OpenCensus, and OpenCensus is an instrumentation specification for libraries. And so it means that it doesn't only do like tracing, it also does like monitoring and instrumentation. So you can mark events in your application and they get exposed in some format. They may be configured to be pushed to InfluxDB, so they will be converted in InfluxDB, or they will be exposed to Prometheus, so you will get the /metrics endpoint. And obviously, Google didn't really took the open tracing standard. They developed their own flavor of the.
But of course.
So now we had a very good set of libraries from Google that does monitoring and tracing, and we had the open tracing community that was way ahead, and they had a lot of
like
code
two parallel tracks.
Two parallel tracks, and they was always fighting between each other. So they end up being merged together in open telemetry. So the open telemetry story is already a good picture. It gives you a good picture of like the complication in collaboration that we have. But at least they got able to have the common name now. So I hope this is a step further on that, and that finally will be a solid like project that we can all rely on.
Nice. So just kind of recapping, discussing SRE, discussing observability and telemetry, where do you see SRE going in the next couple of years, I guess?
Yeah, I mean, I think we are figuring out, and we know that observability and reliability requires some work from the developer now. So we know that based on your language, you have to inject a bunch of libraries and use them. On you have to, as a developer, to be mindful about how you are logging, because logs are not random print line anymore that you watch as a daemon doing a tail and looking very hard in your screen. And I have a colleague that used to do tails, and based on the speed of the log, he was able to say if the application was like underload or overload. So it's like, oh, nobody's using the application today, or oh wow, this is too much traffic. Just looking at the log, but at the speed of the log. But this doesn't work anymore, luckily. So even logging requires some mindful thought around, because those logs are used from other people. They are used for automation. So I think we now are kind of on board with that. So the next things to me is that we should really have a good at least vendors are doing that well, some of them. In open source, we have some attempts, but we don't really have like a full, easy to use like monitoring solution yet. Like we have, we can hook together stuff efficiently, but my dream will be to have, a way to jump in between traces and logs and aggregation and see alerts, all this stuff in the same place, because there is already a lot of complexity in understanding the metrics, taking the right one, using them, make the right aggregation, write the good alerts. So there is already a lot to learn and to do wrong. So we have to. I presume that the next phase will be to kind of consolidate this in a much more friendly tool chain.
Okay, I like that. And
I hope so.
Yeah, well, I mean, we have to go that way. I mean, that's the thing, is we need to make our lives easier, not more difficult.
Yeah, I mean, this is something that I was discussed with my colleagues as well recently, and we are in the unique position to design and build in a way that will make us happy. And usually, when we are happy, it means that we are happier to maintain the code that we write. So, when I'm always thinking about this idea of like Java developers that has these strict rules when they have to have an interface and an abstraction for every class, even if they will never use it. So this to me always end up to create a huge amount of like frustration to the developer, and we are the cause of it. So yeah, be friendly to yourself and your colleagues. Design something that you are happy to work with, like for a year or two at least.
That's quote worthy right there. I like that. And the next project, the final project we'll discuss, is probably the largest impact on the community, and that's you're part of the SIG Kubernetes release team. And so what's your role in that, and what's coming next for SIG Release?
Yeah, I mean, if you don't know anything about Kubernetes at all, like how it governed and how it is managed, there are SIGs that are group of people that works on a specific part of the ecosystem. So we have a SIG node that works on the kubelet and on the node lifecycle. We have a SIG instrumentation that works on like monitoring and observability for Kubernetes. And we have a SIG cluster API that works on the API and things like that. So the SIG release is the one that manages the release lifecycle of Kubernetes. So the responsibility for them is not to tell what will go inside or outside the release, because every SIG has responsibility for that. The SIG release just tries to figure out and to keep the lifecycle process going smoothly, because as you can imagine, there are like thousands of developers, but also thousands of users, and those users are of different kinds. So cloud providers, for example, one of the big discussions we are having now, and I think it's a great one, is related to the particular situation where we are now. So all the companies are maybe closed, or they are working not at full capacity, but a tiny bit of companies, and I'm thinking about cloud providers, they are working at almost at full capacity because they can work from home, they can keep their business going. So the SIG release is kind of trying to figure out how to make the release good for everybody. So it has to be, we can't stop a release because there are developers that are working and code is already merged for the 1.19 release.
Yes.
So it will, it has to happen. There are people that committed their time already. There are companies that made plans around 1.19 already. But there is also, this is like a unique situation. So there is also, we also have to keep in mind that other companies that are not cloud providers, may have like problems if they want to stay up to date with Kubernetes release. And this is something that usually you want to do because there is so much changes going on every release that you kind of, if you miss a train, you will probably miss all the others in some way. So this is one of the discussions that the SIG release in collaboration with the community is having right now. So how do we have to do something in the process to keep in mind and to make everybody as most comfortable as possible in this situation? And I thought it was a very when the argument started, I thought it was a very like friendly one to have as a community. So it really made me to think about how solid the community is, because we thought about all the people involved in the life cycle of a Kubernetes release. And so yeah, I mean, to get back on the general stuff, like the SIG release is split in like different working group, and okay. I'm currently leading the bug triage one. That is the group that release by release tries to get as most bug fixes inside the release. That's it.
Oh wow.
So and like it's made of like there is a lead that is responsible for the group, but every release we ask for help from the community. So there is a process of selection of shadows that you apply, and you can get on board and work with me on triaging bugs in this case. And the cool part is that you don't have to be like, if you think about like every time you start to contribute to a project, you think that you have to be full on it and you have to know everything about it. But the time I spent in the Kubernetes SIG release is mainly like chatting with people, trying to figure out their issue, try to unblock them. So there is no code involvement at all. So even I like one of the person that worked with me wasn't even a developer. It was like a project manager.
Really?
Involved in Kubernetes, and because there is a lot of chatting and pinging people.
More organization of the project.
Yep. Yeah. So the SIG release is definitely a good place if you are not a developer to help Kubernetes itself. There are others, like the documentation one is also a good one, so you can join the documentation. So you don't really have to. What I'm happy to say is that you don't really have to know everything about Kubernetes or have to use it for years. You can be whoever. There is a place for everybody. So just get on board.
Sorry, there's typical COVID pause for a moment.
Daddy, I want to watch.
I have to turn on the radio again for my son.
No worries.
Lego City. All right.
Lego City. Abenteuerwelt. All
right, pick which one you want, buddy. Yeah. So his playlist is over, so I have to start the new Spotify playlist. All right, so I'll cut that part out, don't worry.
I mean, if it's okay for you, it's okay for me.
All right, cool. So your involvement in the next release, you're going to be, what are you doing for the next release? What's your involvement for the next release?
Yeah, for the next release, I will lead the bug triage working group for the SIG release. So we are like 5 people now. We assembled the group, and I will go. Like the idea is to, as soon as the code freeze approach, like Kubernetes has a very one of the reasons about I was happy to be involved is because you see how a huge project like Kubernetes gets managed. And so there are different phases in the release week by week, and one of them is the code freeze. So it happens when we cut the branch for the release out of master, so no new code can go inside other than like bug fixes or hotfix or whatever. So it means that everything that has to get inside Kubernetes 119 in this case has to go before code freeze. So a few weeks before code freeze, we start to have a look and grab from the GitHub API all the issues and pull requests that are marked with specific labels and specific milestones. And we have to figure out with the community which one we go there, which one won't, and so on. and get the community and the companies to merge their pull requests. So this is the involvement I have, and I'm focused on the bugs.
Okay. I think you really highlighted some important points, and I think it's a misconception in the Kubernetes community as well as open source generally, is that even if you don't write code, you can still help with these projects. So like you mentioned, like this project manager is also helping, triage issues and things like that. So I mean, we need the help. Even if you don't write code, if you can help with documentation or organizing or like reading issues, it just helps everyone.
Yeah. I mean, even writing issues is a huge effort, because as more effort you can put writing your issue, as more you are helping somebody else in the other, in front of its laptop. So yeah, I mean, even as a normal user, if you encounter an issue or if you think you're encountering an issue, the way you should put all the effort you can in writing the issue itself, because that will help contributors to make better choice or to have less work to do. So everybody can help. It just has to be, and definitely we have to develop, the community has, and the open source project has to develop the right environment for everybody to feel useful. But in a community so big like Kubernetes, there is so many structured, and people are kind and usually helpful. So I think it's a good community for non-developer to help.
Well, great. I think that was. I think we covered all the SRE topics. We covered, the projects you're working on. I mean, it was. I got a lot of great information from this. I hope everyone else did as well. We will put all the project links in the show notes. We will put Gianlucca's website, his GitHub, Twitter, Twitch, every social that's manageable out there. We'll scrape the internet for him and put in the show notes. So we thank you very much, Gianlucca, for your time today. And it was very insightful about, your thoughts on telemetry, on SRE, and also the Kubernetes community in the SIG release train.
Yeah, so thank you for your time. It was great to be here and to have the opportunity to chat with you. So thank you.
Thank you for listening to this episode of The Byte. You can find the show notes at thebyte.io and follow me on Twitter at I Do My Own Tricks.